Hi everyone, today's lesson is for Algebra 2 honor students. This is chapters 7 and 10. Section 10-4, graphing polynomial functions and the fundamental theorem of algebra. So let's get started. Let's start first with a warm-up. Warm-up says, using the rational zeros theorem and synthetic division, find all of the zeros. So what we've learned in the past is that the rational zeros theorem states that we can find all the zeros by taking the value of here, which is that constant, -2, and the value of the coefficient in front of the highest power, which is the 4, and we can find all the zeros, the possible zeros. Now, that's not, all the zeros that I'm finding are not all of them, it's just the possible zeros. So we would say, you would write it like this, P of x over Q of x, and these are just to find the rational zeros that could be possible values. Okay, let's try to make that straight. All right, so you would take all the factors of -2. So the factors of -2 are plus or minus 1 and plus or minus 2. And then the factors in front of the highest power, which is the coefficient 1, is just plus or minus 1. So it looks like all of the rational possible zeros that we could have to plug in to our synthetic division problem so that we could find all the factors are 1 over 1, 2 over 1, like that, and then they're opposite. So we could say plus or minus 1 over 1, and then we would say plus or minus 2 over 1. And so by doing this, I'm going to start plugging in values, okay? So we can just start with pick 1, so you can pick 2. Normally, though, make sure that a couple things, that this is in descending order. So it goes 4, 3, 2, 1, 0. There's that x to the 0 here that we know is there. We don't write that, but we know that that's there. And then you're going to put, because it is synthetic division, you don't use any of the variables. So we have 1, 1, -1, 1, and -2. And so what's happening here is I'm going to add down, and I'm going to multiply across. So that's going to be 2. Add down, I get 3. Multiply across, I get 6. Add down, I get 5. Multiply across, I get 10. And what's happening is these values are getting increasingly higher, and what I really want is a 0 here, and that's not going to happen. So I'm going to erase this, and I'm going to start over again, and I'm going to start with a different value. Okay, so 2 did not work. And if you're keeping a running tab, you've got 1, you've got -1, you've got 2, and you've got -2. So let's see, we just tried 2, 2 didn't work. Let's try -2. Add down, multiply across, add down, multiply across, add down, what is that? 2 minus 1 is 1. Add down, so I get 1, multiply across, I get -2, add down, -1, multiply across, I get 2, add down, I get 0. Success. So this means because I have a 0 here, that means that -2 is a 0. It also means that x plus 2 is a factor, okay? And so what I have left now, remember that if you have x plus 2 here, what's left? See how this is to x to the 4th power, and let's say we're dividing by an x value, x to the 1 power. What's left is going to give me x to the 3rd power. So that's 1x to the 3rd minus 1x to the 2nd plus x, which is because that's positive 1. So plus x minus 1, and then we're done with that. So now where we're at is we need to factor this cubic polynomial. Okay, so we're going to do that. So now I'm going to try another value, and I'm going to try 1 and -1. So there's a 1 here, -1, 1, and -1. Because remember, the factors now, my rational root theorem, my new factors are just plus or minus 1. All right, so here we go. And I'm going to try 1 first, and let's see what happens. So add down, multiply across, add down, multiply across, I get 0. Add down, I get 1. 1 times 1 is 1. -1 times 1, add 1 is 0. So now I know also that x minus 1 is a factor and that 1 is a 0. So now what's left is this. So I'm going to rewrite what I have. I've got an x plus 2 times, and you're going to take this opposite of that and opposite of that. So then you have x minus 1. And then now you have what's left. Now remember, if it's an x cubed, right, and then you have a 1 down here, that's going to be, you divide it by an x, so now that's going to be x squared. And so now that's 1x squared I have no x term. So I don't need to write my x term, but then I have left plus 1. And so that equals 0. So my factors are this. Now keep in mind, I want to show you something. See this x squared plus 1? We know that if we were to divide these up and set these equal to 0, right? X plus 2 equals 0. That means x equals negative 2. That's a factor. Excuse me, that's a 0. This is the factor. X minus 1, so x equals 1. That's another 0, which means that if I was graphing this on a, a graph axis, xy axis, I'd have at negative 2, I'd have a 0, and at 1, I would have a 0, which means my graph is going to cross that. It also means at negative 2, for sure, I have a y-intercept. And also, this is to the 4th power, which we are going to be discovering today. Even powers do go up. Those are my end behaviors going to go up, up. That being said, this is happening here. And if I were to set that equal to 0, I'd get x squared equals negative 1. And when I square root both sides, I get x equals plus or minus I. So realistically, my factors are if they want to know what are all the factors, or excuse me, what are all the zeros, my factors are here. These are my factors. But my zeros are going to be negative 2, positive 1, and plus or minus I. So those are all my zeros. Cool. Okay, so our learning targets today are to talk about end behavior and multiplicity. That's a big deal. I did start talking about this in my last lesson on day 3. So if you didn't get a chance to watch that video, you should try to. Be able to analyze the zeros of the fundamental theorem of algebra. What is that? Plot the graph, and you possibly use synthetic substitution, and then find all the values that of x that make the polynomial equal to 0. That means I want to find all of the x-intercepts or my zeros. Find all of the zeros, because sometimes my zeros are not going to be real numbers, right? Okay, so going back to, let's just go through this. What is a polynomial? Polynomial comes from many, nomial means terms, so many terms. Polynomial can have constants, variables, exponents, and the cool thing about polynomials is if you add polynomials up, you still get a polynomial. If you subtract polynomials, you still get a polynomial. If you actually multiply polynomials, right, you multiply polynomials, you're still going to get a polynomial. However, when you divide polynomials, you may not get a polynomial. Sometimes yes, and most of the times no, which means that most of the time a polynomial is constant. Like it has no, it's smooth, right? It doesn't have any breaks in it, no asymptotes, no holes. A polynomial is just smooth going, right? But when you're dividing by 0, see that x on the denominator? What ends up happening, remember our parent function, what this actually looked like? It looked something like this, where we had a not smooth graph. This has a break in it for sure, right here at 0 and also here at 0. So there's a break there. So that's something that you have to be conscious of. Anything that's divisible by x is not going to be something smooth. It's not going to end up being a polynomial. We know that, again, adding polynomials, you get a polynomial. Multiplying them, you get a polynomial. Same thing with multiplication. For this problem right here, I want you to notice something. This has the highest power of x to the 4th. In the first 2 days, we've been doing a lot of x cubed problems and a lot of graphing problems, which we know that the graphing of these kind of looks something like that, right arm up, left arm down. And then our end behavior that we talked about in class, see the arm up? So that kind of looks like this, up and then down, right arm up. This is what we call the end behavior. That's like what's happening at the end of each of the graphs. Well, for this one right here, though, if you notice that at this end of the graph, it's going up. And at this end of the graph, that's also going up. Because anything that has an even power that's positive and is a polynomial, it has to be a polynomial, is going to have this end behavior. And so the end behavior for an even polynomial function is going to be up, up. And likewise, if it's a negative, meaning I have a minus sign in front, the end behavior will be negative, down, down. So these are polynomial functions. They're continuous, they're smooth. See, that would be an even function, end behavior, up, up. This also smooth, right? This one right here, this is just a constant polynomial. This one right here is a cubic, right arm up. See how that is? So that end behavior would look something like that. And this is a negative x to the fourth, which the end behavior goes down like that. That also, all of those on top are continuous, they're smooth. The ones on the denominator, though, are not continuous, they're not smooth. Notice that this one kind of stops and then comes back up. This is an absolute value one. This right here that starts here and then goes to the right, this is a square root one where there's a variable under. And we already know that these are not polynomials. This one right here is some sort of exponential polynomial, which is x to the 4/5, it looks like, which would be 4 and 5 here, also not a polynomial. And this is a polynomial with a variable on the denominator, and it looks like we have an asymptote at 1. Which also makes that a break in my graph, and it makes it not a polynomial. So going back to the terms, right? What kind of terms we have? Anything that is a squared term, that's quadratic. We talked about this in class. The first term, that's linear. We have a constant term. That's when you have x to the 0 power. If you have x to the 3rd power, that's a cubic. And then x to the 4th term, we call those quartics. This one right here, it's a quartic. And then the 5th term is what we call a quintic. Okay? And that's just because the highest power is the, you name the polynomial by the highest power of the polynomial in the variable. So what is the degree of the polynomial? The degree is always going to be the highest power. This right here, the cubic, so that you would say this is a cubic 4-term polynomial. This one, notice they didn't put this in order, but this is an 8th power, and we don't actually have a name for that, so we say it's an 8th degree 4-term polynomial. This one right here, this is a first term, so that's a linear, and because I have 2 terms, it's called a linear binomial. And then lastly, we have 1 term, and this is x to the 0 power, which is a constant. And we call those constant, and then because it's just 1 term, it's a monomial. Okay? So the leading coefficient is like, has all the power, okay? You've got to find the highest power. So in this case, the LC, or leading coefficient, or leading term, so my leading term in this problem on top is 7x to the 4th. But my leading coefficient, but my leading coefficient, all right, my leading coefficient, my LC, is actually just the value of the number in front, okay? So in this problem here, my leading term is 4x cubed, because that's 2, that's 1, and that's 0. That's the highest power. It's a cubic, 4-term cubic, but my leading coefficient for this problem is 4, all right? So so good review for that, just what is a polynomial and what makes it, how do I distinguish what it is? End behavior, super important topic. As you may have known in the last couple of slides, I've talked about when you have the end behavior, or the ends of my graph are both going up, that has to be an even power. And then so this basically is going to be some sort of x to the even power. So it could be x to the 4th, x to the 6th, x to the 8th. We don't really know. What we do know is this, is that every time I turn, that's another power. So like if I turn once, twice, 3 times, if I've turned 3 times, the way it started was, if this was x to the 4th, in order to find my actual turns, that's going to be n minus 1, and this meaning that's n. So this does look like it is an n to the 4th power. However, I mean, it is very likely that your graph is going to do something like this. And we don't necessarily care what's happening in the middle if we're just looking at the end behavior. So how to find the end behavior? You've got to look for the leading term. All right, that's most important. And in this case right here, this is an x squared. So that means that if it is an x squared, most of the time, because it's even, right, my graph's going to go up, up. However, because this is a negative, this is going to flip my graph, right, upside down. So now my end behavior is going to look like this. And this one right here, it's going to be up, up. So most of the time when you're graphing something like this, right? If it was a positive, it would go up, but this one's negative. So this could go down like this, down like that. And that's what this is. And additionally, this one up, this one up. This is called end behavior. Don't be alarmed if you see somebody writing, your end behavior like this. Some people do that, and that's completely fine. I like my end behavior straight, but putting your end behaviors curved is completely fine. Also, an x to the fourth power that's positive also is going to be up and up. And so what that means is something's happening here and here. That's my end behavior. Not sure what's happening in there, but I do know that the turns I'm going to have is not going to be more than 3 if it's a fourth power. Now, for a cubic, though, right arm up. For a cubic, if it's positive, it looks something like this, right? So if I were to write my end behavior, I would write right arm up, left arm down. And that's only, it's not asking you what's happening in the middle. They don't care. This is called the end behavior. They only want to know what's happening on the ends. So this is what this is saying, hey, oops. This is saying we got a leading term test, and with the leading term test, if it has an even degree, x squared, x to the fourth, x to the sixth, and it's positive, then your graphs, your values are going to go up like this, and then my end behavior looks like that. If it's even and it's negative, meaning that value, your polynomial leading coefficient value is less than 0, right? It's negative. Then your end behavior is going to go down if it's even. And like I said, see all this like squiggly? That's not what we're looking at. We're looking at the ends, the end behavior. But if it's odd, like if it's x to the 1 power, or if it's x to the 3rd power, or if it's x to the 5th power, your right arm here is going to go up, left arm is going to go down, okay? If it's negative, then your left arm, and so this for a positive cubic, your end behavior looks like that. For a negative cubic, your right arm is down and your left arm is up like that. So this is a little chart for end behavior, and it just basically says, hey, this is even, these are up, up, down, down, these are even. So end behavior, up, up. This is an x squared, down, down. If you have a negative leading coefficient, your end behavior is negative. For this one, up, up. So this looks like turn once, turn twice, turn 3 times. This is probably an x to the 4th power, positive. This one goes turn once, turn twice, turn 3 times, and it's going down. My end behavior is going to go down, down instead of up, up. Likewise, for an odd polynomial, so meaning any kind of odd, x to the 5th, x to the 3rd, any kind of odd polynomial, right arm's going to go up, left arm's going to go down if it's positive. So my end behavior would be up and then down. Also, this is positive because my right arm up, left arm down. But for this one right here, this is a negative, meaning when I looked at my graph, let's say my polynomial might look like that, negative x to the 3rd. And so that's going to be a left arm up and right arm down. And similarly with this. And this one definitely is not a cubic because it does look like I'm turning a couple times. 1, 2, 3, 4, 5. Wait a minute. 1, 2, 3, 4, 5. Probably 6 times because remember the terms is always going to be less 1. So if I have 6 turns, then I would have a 5th power. Okay, so actually I said that wrong, didn't I? Sorry about that. If I have a fifth power, then my terms is n minus 1. So these are my terms. So write that down so you have that like little formula. So that would be 4 turns for sure. Okay. Okay. So for this, all I want to know is what the end behavior is, and you could kind of sketch it. It might help. I'm not asking you to graph these on your calculator or anything like that. I only want the end behavior. So you're going to take the highest power. So this is x to the 0, not the highest power, x squared, x to the 6th, highest power. That's my leading term. That's the leading term. That's your LT. Now my leading coefficient is -2, but is negative. And my power is even. So what that means is that it's my power would, my end behavior would either go up, up if it was positive, or down, down if it's negative. And this is what it is. So it's not positive. So it's negative to the 6th. So I do know it goes through -7, that you can decide whether or not you're going to put that into your graph or not, but you would just do a sketch. Because this is a down, down, this is going to go, looks like 6 powers. So I'm going to have like 5 turns. 1, 2, 3, 4, right? 5, okay? And that's what it would look like. For this problem here, so my power, you got to multiply these out. This is an x cubed. This is an x to the 1. This is an x to the 1. So that's going to be 3, 4, 5. That's an x to the 5th power. My leading term, look at your x's. That's positive, 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 positive. So that's a positive x to the 5th power, which means that it's odd. And if it's positive and it's odd, my end behavior is right arm up, left arm down. So that means that my graph will go up this way and down this way. And I've got 4 terms inside there somewhere, n minus 1. If you really are like a strickler, like you're really like have some, you're worried about, I have to have this graph right. I mean, you could definitely look for the y-intercept, right? -3, -3, -3. That's -27 times 2, -54 times 3 times 2. What is that? -54 times 6. Hold on a minute. I can do that. Let's see. -54 times 6. Oops. Okay. -54 times 6 gives me -324. So way the heck down here, I'm going to have -324. That's my y-intercept. That's what happens when x is 0. So we're going to have, this is going to go up, down, and I've got 4 turns. This, I don't know. You just kind of make up a graph. It doesn't really matter what's happening in the middle. And even this, if you're just drawing the end behavior, this is completely fine. Watch, you just go through this 1, 2, 3, like just like that. That's fine. This last problem here is you think it's a cubic, but it's not, because see this 4th power here, watch for that. It's positive, it's even. That means it's going to go up, up if it's even. And it's the 4th power, the 4th degree, which does, and this is my end behavior. And some people call this EBA, call it end behavior, because there's another option. Anyway, this is my end behavior. And plus 4 is positive. So I know that this is going to go up, this is going to go up. And then there's like stuff happening down here, but don't care, right? I can even say that this is -1. When you're graphing a sketch of this end behavior, you're just graphing it. You're in this like stuff happening in the middle, but the ends are what you're counting. This is just calling, what is this? Leading term test for end behavior. So if n is even, you should have up, up. If n is even, but it's less than 0, it's down, down. If it's odd, right arm up. If it's odd and negative, left arm down. Okay? So the number of turns, we were just talking about that, and I guess I jumped the gun a little bit. This is n minus 1 terms. So if a polygon has is a quadratic, like let's say it's an x squared, then you're going to have 1 term, okay? Because you're a second power, you're going to subtract 1, you get 1, that's your number of terms. It's always going to be n minus 1 terms. Standard form of a polynomial, I'm going to be asking you to put your answers in standard form. And it could be the right answer, but if it's not in standard form, you don't get credit. So you have to have it in standard form, okay? So 3, 2, 1, 0, check standard form, okay? 8, 7, 8, this is not standard form, okay? To be in standard form, it has to be descending order, okay? That's it. See the descending order of the power. All right, so this is just saying find the zeros of the factored polynomials. This is kind of cool because we want to know if we've got this right here. So if I'm looking at problem number 1 and I want to know what my zeros are, well, this has already been factored. So I can tell you that my zeros are ... 2. You're going to set each one of these equal to 0, okay? So you're going to say 2. Oh, wait, I have another 2. And I have another 2, and then I have -1. Now, this is a little bit interesting because I'm going to go ahead and talk to you about what's called multiplicity, which is we're going to be talking about next. Well, in a minute anyways. I have three twos. I have three twos, which means this. If the number of factors is odd, we call that it has a multiplicity of 3, so that's an odd number. That means that my graph, whatever it's doing on my axis, is actually going to cross there, my x-axis. It's going to cross my x-axis. That's what's happening, okay? And then in this problem here, in this one, see how I have a factor of -1, one of those? That means I have a multiplicity of 1. Also, I'm going to cross. Now, some people, like if this was my x-axis, right, it means that it's going to cross right there. And if it's, so let's just draw a sketch of this real quick, okay? It looks like it's to the x 1, 2, 3, 4th power, okay, 4th power. And if I were drawing a sketch of this one, it's if it's to the 4th power, right, that's even. X to the 4th power is even. I know and it's positive, yep. I know my end behavior is going to be up, up. I also know that I have 1, 2, 3 twos. So at 2, my graph is going to go through there. If I wanted to know what my y-intercept is, I'm going to go, let's see here, x is 0. So I've got -2, -2, -2. So what is that? -8. -8 times 5 is -40. And -40 times 1 is still negative. Okay, so we're down here at -40. So I know that here my graph is up. And then on the left also I have, -1, right? -1. And I know that my graph is crossing there. But it's crossing there also. Okay, so it's going to go through that also. And it's going to go up. So realistically, my graph is going to cross at -1 because it had an odd number of factors, right? And it's going to go down here and it's going to do some weird stuff down here. And then it's going to come back up here because it's going to cross at 2 because it has an odd number of those factors. All right. So that's what's happening. That's what that means. Now let's look at the second one, g of x. Now g of x, let's see. Oh, don't forget to see this little negative sign out front, by the way. Okay. This is 1, 2, 3, 4. So that's an x to the 4th power. Negative, okay, which means that my end behavior is going to look like that, down, down. My factors, or my zeros, are 1, but I have 2 of those. So I have 1. So I would write like zeros right here, and I would put 1 with a multiplicity of 2, because I have 2 of those. And then I've got -2 and -2. So that means I have 2 of those. Okay, so what that means, now if they were odd, I crossed the axis right through there. But if these values are even, if I have an even number of the same zeros, that means that my graph at that point is what we call tangent. And a lot of people will say, hey, tangent, it kind of like hits the bottom, hits the 0, boom, and then comes back up. So a lot of people will not say tangent. They'll say, oh, it bounces off the axis. So it does bounce. Okay, so it bounces. So let's just draw a graph of what we think this would look like. So we do know that this is a negative graph to the 4th power. All right. And so then I know my end behavior is going to be down, down. I know my zeros are 1. So I've got 1 at 1. There's 1. And I have 1 at -2. But I have 2 here, 2 here. So those are my end zeros. So that's down. That's also down. What's my y-intercept? Let's see. It's going to be -1 times -1, which is 1, times 2 is 2, times 2, which is 4. -4, because of the negative sign in front. So it does go through here. So I think it goes through there. Yeah, it does. Okay, so what's happening is this. Let's see. So my graph is going to come up at 1. See here? It's going to go up. Let's see. I'll try to use green. It's going to go up here, bounce off a -1. Boom. Might go through there, right? And then it's going to come back up, and it's going to bounce off of -2. and go down. It is not going through -2, because if it went through -2, right? If it went through, then I would have had an odd number of multiplicity, an odd number of zeros, but I don't. I have an even number, not an odd. Okay, cool. We didn't do 3 and 4 yet, so I'm going to actually take a moment, pause, and then do those on the next page. So give me just 1 second, pause record. Okay, so for number 3, this question says, determine if 2, 3, and -1 are zeros of the function. So you have a couple of options to figure this out. Number 1, you can use the factor theorem. And the factor theorem would say this. If I were to plug in f of 2, right, and I would plug this in here, I would go 2 times 2 to the third power minus 3 times 2 squared plus 2 plus 6, and then I would work this out, right? I would say I would work this out on my calculator, and this battery's low. Okay, so I would work this out on my calculator, and or I would plug this in to my calculator, and that would be a lot quicker. So let's look at and see what happened with that. Okay, so if I said y equals, and I need to delete that. If I said y equals, so let me bring this down here. I'm going to type that in. So I would get 2 x to the third power, so up to the third power. Let's see, where's that? 3. And minus, so we're going to go minus 3x to the second power, and we're going to go plus x, and then plus 6. And we're going to graph. Okay, so there's my graph. All right, so now something that you do know is that you do know now what it looks like, but I didn't do this for that. I did this for the table. So I would go to second, let me move this up. I would go to second and then graph, because that's going to give me my table. And if you notice here, these are my values here, right? I have a 0 at -1. The values that they want to know are 2, 3, and -1. So if I'm looking at 2, nope, it's not a 0. 3, not a 0. And -1, not a 0. So I'm going to take a picture of this real quick, just so you have that. And I'm going to put it here for 1 minute, because in doing this right here, right, if we're looking at whether or not these are zeros, I mean, this is definitely an easy way to do it, right? You've got all the values, and you definitely save time, etc. If I plugged in 2, what I ended up getting here, right, was 12. Now, while it's not a 0, because if it was a 0, this would be 0, okay? 2, 3, f of 3, plugging in 3, we get 36. And then f of -1 is 0, okay? And by the way, when they ask me for what my zeros are, they're not asking me for my y-intercept. They're not asking me that. It's important to know what the y-intercept is, but they're not asking me that. But while I know that at -1 we have 0, that's one of my zeros, okay? F of 3 is equal to 36. That's a point on my graph. It's not all for naught, because you found a point, you plugged in 3, now you got 36, but it's not a 0. So what that means is that 212 is a point that we found, and also 336 is a point. For this one right here, determine if 2 and -5 are zeros of this function. Another option, so I've given you already 2 options here. I've given you this option here where you're plugging in these values, right? And it's called the factor theorem. I'm giving you this option, which is using the graphing tool, using your calculator graphing. But additionally, you could just plot, use these values for synthetic division. So that might even be quicker than actually typing in the equation into the calculator, right? Add down 1, 2 here, add down 3, multiply 6, add down, you get -11, multiplying across, I get -22, not a 0. So I would say, no, 2 is not a 0. And they're not asking me what the point is, so then I'm done. I'd say, nope, 2 is not a 0. And then if I were to plug in -5, I would do that again. And I would do exactly the same thing, take all of this here, and then just say plug in -5. And so I add down 1, multiply across, I get negative 5, so that's negative 4, which is 20. Negative 17 plus 20 is 3. 3 times negative 5 is negative 15. Add down, I get 0. Yes, it's a 0. And if, as a matter of fact, I wanted to know what all of my zeros were, I would then finish factoring this, right? Because I know that in this problem here, I know that x plus 5 is a factor. Even though negative 5 is a 0, x plus 5 is a factor. Additionally, 1, negative 4, 3, this goes with this. So if it was a cubic, x cubed, then this is going to be x to the second power minus 4x and then plus 3 equals 0. Factoring that is going to give you x plus 5. It's going to give you x minus 3, and then it's going to give you x minus 1. And so my zeros are negative 5, positive 3, and 1. And what that means for me is if I were to graph this on an axis, right, I would have a 0 at negative 5, put a circle there, point there, 3 here, there's 3, and 1 at 1, here's 1, okay, and there'd be points there. Also, negative or positive 15 is my y-intercept. Not a 0, but it's still it's not my intercept. So my graph, and look at the power. This is an x cubed. What that means is if this is an x cubed, you know that the end behavior is the right arm up, left arm down. So right up, this is end behavior, EB. So if I were graphing this, right arm up goes that way, left arm goes down this way, and then the rest of the graph just sort of smoothly follows the points, right? I'm going to have to go up. It's going to go probably through that point, of course, go down. I'm not sure how low it's going to go, and then it's going to turn around and come back up. This is definitely a sketch of my polynomial graph up here that we started with, to see if the zeros are there. But it's a sketch, but it's something that you can do. And, you can do the end behavior. You can figure this out. You don't need a calculator for that. We're going to delve into more multiplicity. It just means that the real, that is basically non-complex zeros, complex meaning imaginary, correspond to the x-intercepts. So if you know the number of real zeros, the number of zeros that you have, right, that's going to be the same as your power. But within that, the values that you find for the zeros, that's going to depend on if your graph is going to cross, okay, and sometimes people use the word intersect, so you can either use cross or intersect, and that's if you have an odd multiplicity, okay, but if you have an even multiplicity, what that's saying is that your graph is tangent, meaning it's going to be bouncing off at that point. So you can say tangent, or you can say it bounces, okay? So what we have is this. We have these factors. Now we're kind of going to go backwards a little bit. I'm telling you that a polynomial has these zeros. So what are my linear factors? So you would make up a polynomial, p of x, okay? So these are my zeros. So if I was working backwards, I would then say, well, to get 3, I subtracted that x minus 3, and I had an x plus 5 then, and then I had an x minus 2. So this is what we call linear factors. So if I ask you to write the equation out in linear form, in linear factored form, okay, with factors, this is what I'm expecting you to do. I'm not asking you to multiply this out because that would be standard form. I'm just asking you to write it out. So this would be the question, or the answer anyways, sort of like with Jeopardy. It's like the answer is the question. For this problem down here, I'm giving you a polynomial. I'm telling you what the zeros are. I don't want you to multiply it out. I just want you to tell me all the linear factors. And so if there's any multiplicity in there, I want you to tell me what that is. So you would say p of x. And as you're working through this, you should pause the video anytime that there's a problem like this, and then try to do it yourself, and then check your answers. So I've got 2 5s. So I could start off by going x minus 5 and x minus 5, okay? Then I would go x plus 7, because these are the opposites, right? And this is going to be x minus 2. I've got an x minus 1, and then I've got an x minus 0, which means this. I've got 2x minus 5s, okay? So that's going to be x minus 5 quantity squared. Okay, those are done. I've got an x plus 7. I've got 1x minus 2, so that goes here. And then I've got an x minus 1. But I also have an x minus 0, which is just x. And so that value is going to go out front. Now, if you were, if you had factored your equation down to this form, right, then you would split all of these up and set each equal to 0, and then you would get your zeros, right? So we're going backwards. So what this does is it tells me this. It tells me that I have 0. So I would ask you, what are my zeros and what is the multiplicity and what is happening at those graphs? So what are my zeros? My zeros are 0 and I have a multiplicity of 1. See that 1, 1, 0. I've got a 5 with a multiplicity of 2. That means I have 2 of those. I have negative 7 with a multiplicity of 1. I've got 2 with a multiplicity of 1. See, this is this one. And then I've got a 1 with a multiplicity of 1. And what this means, people, is if I were graphing this here, okay, put your zeros in. If you were to graph all your zeros, you get a 0, you've got 5, here's 1, you've got negative 7 here, you've got 2, let's say that, okay, let's move that over. Let's say we've got a 2, let's say that's it right there, and we have a 1, okay? And only at 5 is it tangent. This is where it's tangent, right? Everywhere else it crosses through. It crosses all through. So I could draw a sketch of what my graph might look like. And first though, what's my end behavior? What's my power? I've got 2, 3, 4, 5, 6. I've got a 6 power. I've got a 6-degree polynomial. And my graph happens to be positive. So it's a 6-degree positive, which means that my end behavior is even, so it's going to go up, up. So I'm going to find the end values, which is there and there, and that's going to give me up, up, okay? And then in between, everything else is going to go through or cross or is tangents. But at 5, it bounces off. It's tangent. So at 5, it's going to bounce off, check, and then it's going to go up. I'm not sure how far it could go, super high or not. We don't care about that. It's just going to kind of come through, it's going to go through, it's going to go through, and then it's going to go through. Because all of these multiplicities are odd. And if it's an odd multiplicity, meaning there's only one of those, of the zeros, that's an odd multiplicity, and it's going to go right through. Okay, so here we go. I don't want you to multiply this out and put it in a standard form. I want to know what my zeros are. This is not a 0. You only have a 0 if it's an x equals. Okay, so then a coefficient in the front is not a 0. So we have a 2. So my zeros are 2. But how many 2's do I have? I have 1, 2, 3 2's. So 2 to the 3rd power. I've got a negative 1, and that is to the 1 power. And then I've got 2 of these, which is negative 3, and that's squared. So if I were to rewrite this like they asked me to, I would go f of x is equal to 0.25 times x minus 2 to the 3rd power times x plus 1 to the 1 power, and then x plus 3 to the 2nd power. So let's see, 2, 3, 4, 5, 6. Again, this is x to the 6th power. If this is positive, it's then going to go, my end behavior is up, up. And so I have 3 2's that are zeros. So that means, so I'm going to write it a little differently because I want you to, this is how I want you to write it for me on the quiz and the test. So I'm going to say, what are my zeros? I'm going to put that at the top, and then I'm going to put a line under that. And you're going to say 2 with a multiplicity of 3. And because it's an odd multiplicity, my graph is going to cross or intersect the x-axis. If my multiplicity is 1, like that, I have 1. I have 1, negative 1. So that's going to be multiplicity of 1, and that's also going to cross the x-axis. I have a negative 3, and I have 2 of those. So that's a multiplicity of 2, which means that my graph is tangent at that point. So if I were going to draw my sketch of my polynomial, I would put my zeros. So 1, 2, I've got a 0 here. I have a 0 at negative 1, 2, 3, and I have 0 at -3. And so label those, please. And then I would look for my y-intercept, right? And that's just going to be, if x was 0, what is it? It's going to be -2 to the third power. That's -8. Oh, let's see. -8 times -8 times 1, and then times 9, and that's 72. So I'm going to go -72, but then times -72, having a little difficulty times 0.25, and that's just -18. So I know that at -18, my graph crosses the y-axis. All right, up, so that means up right, up left, that's my end behavior. It's crossing all of these except for at -3, it's tangent. So that means at -3, it's going to bounce off that, go up, turn around somewhere, come back down, and go back through there. And so this is like a sketch of what my graph looks like. And remember, in even multiplicity tells us my graph is tangent at the x-axis. So see how I have 2 -3s, see right here? 2 -3s. That's my graph is tangent. Odd means that the graph is going to cross at the x-axis. Now, keep in mind also, do you see this right here where it says I have 3 of those? That means it's a cubic. So this is what's going to actually happen right here. So this graph right here is a little bit different, and I'm going to show you, because a cubic function, you know what a cubic function, right, looks like. Tentatively, it looks like this, right? So that's kind of what my graph is going to happen. So think about this kind of thing, odd multiplicity. If it's greater than 1, it's not going to necessarily go straight through. It's more like a flattening of that right in the middle. So it's going to be looking a little bit more like this, something like that, okay? Where it kind of like flattens there. All right, let's look at this polynomial. I would ask you to pause the video so that you would be able to graph this and then come back and see if you did this right, okay? What I want you to look at is this. I want you to graph, I want you to plot the y-intercept. I want you to tell me the power. I want you to tell me the end behavior. And I want you to tell me all my zeros with their multiplicities, and if the graph crosses or goes through the, or crosses the graph at the x-intercept, or if it's tangent, okay? So pause and then come back. So I'm going to assume you just came back. My power is going to be 4, 5, 6, 7. So this is a 7th power, which means that if it's an odd power, right, my end behavior, and it's positive, right? This is positive. That means that my end behavior is going to be right up, left down, right arm up, because it's like cubic. It's going to be right arm up. If it's just an odd power, this is what my end behavior is going to look like. My y-intercept is just going to be 3 to the 4th, which is 81. So 81 times -5 times -8, which is positive, and so that's going to be 64, and so that's negative. So that value is going to be way down here somewhere, and it's going to be 0, -25,000 something, okay? All right, and what we're doing now is the most important thing that I'm going to look for is to find the zeros, and what are they doing? So if you had an x out in front, that would be a 0 also, right? That would be an x equals 0, 0, but we don't, so that doesn't count. So we have a -3, 0, we have a 5, 0, and we have an 8, 0. And each of these zeros is as if you're setting those equal to 0, so that would be x equals -3. That's where that comes from, okay? So looking at my multiplicity that I should ask you next is at -3, I have 4 of those. So I have a multiplicity of 4. For 5, I have a multiplicity of 1 because I only have 1 of these. For 8, I have a multiplicity of 2. And what that means is if it's an odd number here, right, and this has nothing to do with the end behavior. This has just to do with the zeros. If this is an odd multiplicity, then my graph is going to cross. If it's an even multiplicity, my graph is tangent, which means it's going to bounce off. So it's going to be tangent at that value, or you can write that bounce. And so therefore, let's put our values in. So we have a -3, we have a 5, and then we have an 8. And then we have a y-intercept way the heck down there. So look and see what's your end behavior. It's going to be right arm up and left arm down. And you need to graph that first. That's your end behavior. That distinguishes what's happening with your graph on the ends. And then in the middle, so you're going to ask yourself, at -3, what's happening? Oh, it's tangent, which means that it's going to bounce off that and turn around. It's not crossing the x-axis. It's going to turn around and bounce off. And then at 5, it's actually going to cross there. And then at 8, it's just going to bounce off of that and go back up. And so this is a sketch. Keep in mind, it's a sketch, meaning this could go way, 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 way up there like that. Or this could go way, 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 way down here like that. Just as long as it crosses those zeros at those values, that's what you have to remember. Just here, 0, -3 has a multiplicity of 4, 5 has a multiplicity of 1, 8 has a multiplicity of 2. Even though this polynomial has only 3 zeros, we say that it actually has, because it's a 7th power, it has 7 zeros. And so I want to address that for a second, because if I was looking for, like, how many turns did I just have? I have 6 turns, remember? 7 minus 1, I have 6 turns. So I can see 1 turn, 2 turns, 3 turns, 4 turns. That's what I see. So if I want to add more turns, I can absolutely do that and just go, oh, boop, 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 like that, okay? Or I could go down like this, like right. So it doesn't, like, and what I was doing was this kind of thing. It doesn't matter down here what's happening. It doesn't matter how high it went. What matters are the zeros, check. What matters is the end behavior. And then, of course, you always want to try to graph the y-intercept as best you can, too. So this would be, pause your graph. We're almost done. This would be pause and try to graph these yourself. Find the end behavior, the zeros, and the multiplicities of each. Okay, so pause, start back. Okay, we have 2, 3, 4, 5, 6. This is 6 power. It's even, which means, or positive, sorry, which means my end behavior is up, up. It means that I have a 0 at -5, and that has a multiplicity of 2. It means I have a 0 at 4 with a multiplicity of 1, and it means I have a 0 at -1 with a multiplicity of 3. And what that means is that if it's an even multiplicity, okay, and this, remember, this has nothing to do with my zeros. These are my zeros. That, my end behavior has nothing to do with my zeros. And if it's a 2 or an even multiplicity, my graph is tangent, okay? If it's an odd multiplicity, my graph crosses. It crosses, okay? So let's draw a sketch of this and see what it actually looks like. So we have a 0 at -5. We have a 0 at 1. No, sorry. We have a 0 at -5. We have 0 at -1. And I have a 0 at 4. And for me, when I'm looking for the y-intercept, I'm actually not looking for the actual number. I'm looking for whether or not the value is, the y-intercept is positive or negative, because that just helps me graph. And so this is going to be positive times a negative, which is a negative, times a positive. So this is negative. So that means that it's going to cross down here somewhere. And you're just drawing sketches here. So at -5, oh, put your end behavior in. So I know my end behavior is up, up. And so then it's tangent at -5. So that means it's going to bounce off -5. It's going to come up. I'm not sure how far, doesn't matter. Going to cross through -1, somehow go through that value here, and then cross through at 4. It's a sketch. Okay, for this problem, the second problem, 5, 6, again, it's a 6 power. And so that means, and it's positive, so it's going to be up, up, all right? It's even, up, up. It also looks like my y-intercept, positive times negative, is going to be somewhere negative. It also shows me that my zeros are going to be -7 with the multiplicity of 5 and positive 2 with the multiplicity of 1, which means both of these places I'm going to cross. So at negative 7, it's going to cross there, and at 2, it's going to cross. But in the meantime, I need to put in my end behavior. And remember, it's a 6th power, 6th degree. So it's up and up. And even though I only see 2 zeros, what that means is somewhere in between, there's other stuff happening. And it's crossing at negative 7. So I cross through here, something happens, goes through there, more turns, and then it crosses through at 2, and I'm done. For this last problem here, I've got let's see here, 1, 1, 1. So that's x to the 3rd power. So that means it's a cubic, which means right arm up, left arm down. And so therefore, I know I have zeros at 3. I have a multiplicity of 1. At negative 1, I have a 0 with a multiplicity of 1. And at negative 4, I have a 0 with the multiplicity of 1. So, and my y-intercept is negative times positive, which is negative. So I'm just going to put a negative point there. So I've got 3. So 1, 2, 3. I have a negative 1, and I've got a negative 4. So these are my zeros. So put your zeros in, check. Put your end behavior in, which is next. So we're going to go up, right, down, left, okay? And then now I just have to decide, hey, these are all odd, which means my graph is crossing all of these points at all of my zeros. It's all crossing. So pretty simple. Just follow the curve. So that's going to be, it's going to cross there at 0, cross here at negative 1, some stuff, and go back up at the 3. That's it. So the last 2 problems for today are this. You've got 2 of these. Again, leading term, what's the degree? So this is 1, 1, 1. So it's a 3rd degree. And my leading term is negative x cubed. That means that my graph is not right arm up. It's right arm down and left arm up. My zeros, I don't have an x in front, so that is not a 0. A negative sign does not mean I have a 0. A negative sign just means it's flipped across the x-axis. So I have a 0. Here are my zeros, and you would write those down. I have a 0 at 3 with the multiplicity of, well, let's see. I have a 0 at 1. Oh, and I have another 0 at 3. So that means that my 3's, I have a multiplicity of 2. And at 1, I have a multiplicity of 1. And sometimes, see, that was a little trick. I almost missed that. X minus 1, you might want to sometimes rewrite these. X minus 3 to the 2nd power so that you don't actually almost miss that. Okay, so my y-intercept, let's look at that first, is going to be a negative times a negative is a positive, and a times a negative is a negative times a negative is a positive. So that means that somewhere up here, I'm going to have a positive y-intercept. I also cross the graph at 3, so there's 3, and I also cross the graph at 1, and there's another value here. I know that my end behavior is up, up, so it's going to be up and then down this way. Sorry, up, left, down, right. At 3, though, because this is an even multiplicity, my graph is tangent. Okay, so that means it's going to bounce off of that, because it's tangent. It's tangent to the x-axis. It's going to come down here and somehow go through that value up there. And that's it. Let's see. Did we do all those? Okay. For this one here, it's a power of 2, 3, 4, 5. What is that? 3, 4, 5, 6. So it's x to the 6th power. It's positive. That means that my end behavior is up, up. My zeros are going to be, and I don't have any duplicates other than the ones that are shown, is negative 5 with the multiplicity of 2, 4 with the multiplicity of 1, and negative 1 with the multiplicity of 3. So let's graph those. Okay, so I'm going to make a bigger graph just for fun. And we go negative 5, and I've got positive 4. Let's say that's 4. And there's negative 5. And then I've got here, which is, I'm going to say negative 1. I want to look at my y-intercept because that's going to be negative, positive squared positive times negative is negative times positive. So it's negative. So my graph is down here. My end behavior is up, up. So that's up this way, And at -5, though, that's the only place that I'm tangent. So that's going to bounce off there because it's tangent. It's an even multiplicity. So it's tangent. And another, again, you can just say it bounces if that makes it better for you. 1 multiplicity and 3 multiplicities, those are odd, which means my graph crosses at the x-intercept, right there at the 0. So crosses. Okay, so at 4, it looks like I'm crossing through 4. It is x to the 6th power, and I only have 3 zeros here. So that means that, there's some stuff happening here. So I'm just going to make it like a little wavy. At -1, it does cross. And then at -5, it does have to bounce off. So it bounces back off and it goes back up. So lots of these here, just talking about all these problems. Even multiplicity, vocabulary check. We have even multiplicity. That means my graph is tangent. Odd multiplicity, my graph crosses through. Another option is to say that it intersects. And tangent means that also you can say that it bounces. Multiplicity of 1, that's odd. So that means it would be crossing. A leading term is the value with the highest degree, okay? Highest degree. And end behavior is based on if it's even, and if the power is even, then the graphs are going to go up, up, or down, down. If the end behavior is odd, the graphs are going to go right arm up, left arm down, or left arm down, right arm down, or left arm up. And zeros, all those are x-intercepts. That's what that is. Okay? Okay. Now, last concept is what we call the fundamental theorem of algebra. Okay? These are my factors. And you have to know how to get an equation from factors and how to make it go in standard form, and also what happens with imaginary factors. So we're going to talk about that. The fundamental theorem of algebra is really important. You're going to see that in calculus. You're going to see that on your SATs. It's really important that you do know this. Fundamental theorem of algebra says this, that imaginary factors, they come in pairs, period. If you have positive 1i, then you're going to have a negative 1i. Okay, that's what it means. If you have a factor that's a 2 plus I, then that means that there's another factor that comes with that is 2 minus I. And it's always, another name for that is a conjugate, okay? You always have two imaginary factors. So if I were finding the zeros for this function right here, I'm looking for zeros. I've got x squared, x to the 1, and then here. And this, unfortunately, doesn't look like it's going to factor, so I would set this equal to 0 and use the I would use the quadratic formula, or I would, if I was using the quadratic formula, or I would use even synthetic division, right? So let's use the quadratic formula. So I'm going to go x equals the opposite of b, which is 4, plus or minus the square root of b squared, minus 4 times a times c, and this is all over 2a, so 2 times 1. And what this gives me is 4 plus or minus the square root of 16 minus 32, which is negative 16, all over 2. And what that does for me is this gives me an imaginary answer, and that happening, those are going to be my imaginary zeros. So it's going to be x equals 4 plus or minus, this makes 4i, all over 2. And so I'm going to distribute that 2 to both of my numerators. So my zeros are going to be x equals 2 plus or minus 2i. And so that would be the zeros of this function. For this one right here, it says find a polynomial that has a degree of 3. But my zeros are 2, I, and negative I. So a little bit going backwards like what we were doing before. We're going to call this polynomial of x like this. And I know my n degree is going to be 3, but my zeros are 2. So I'm start off with x minus 2. And to get I would go x minus I. And to get negative I, I'd go x plus I. Now, I would expect that sometimes I'm going to ask you to put this in standard form. Not all the times, but sometimes. So you do need to be able to put this in standard form, which means you do need to be able to multiply this. So in multiplying this, we're going to do this. We're going to go, okay, I'm going to multiply these two terms first, right? X plus I and X minus I. I'm going to get X squared plus IX minus IX, those are gone, and then minus I squared. Now, keep in mind, I squared is -1. So this is x squared minus -1, which is x squared plus 1. So far I've got x squared plus 1. And then multiplying that into the x minus 2, p of x, is equal to, now we're going to get x cubed and minus 2x squared plus x, and then minus 2. And so what I have here is a cubic function that's a polynomial. You would never know that it has imaginary zeros. You would have to keep working on trying to figure out how to find those. Okay, so just recapping as far as degrees and polynomials, finding the largest polynomial, that's going to give me my end behavior. The roots, these are my zeros. That's the graph. That's where the graph equals 0. Again, the fundamental theorem of algebra. Now, I want to talk to you about this because not only does the fundamental theorem of algebra say that I have to have 2 imaginary zeros, but you have to be able to talk about possible combinations and know that, hey, if I give you an x to the 5th power, what does that mean? That means that I could have 5 real, okay, I could have 5 real zeros. I could do that. But at the same time, I could have 2 complex zeros or 2 imaginary zeros, right? And then that would make me plus 3 real zeros. But I cannot have 1 complex zero. The fundamental theorem of algebra states that I have to have 2. You have to have 2, a pair of complex roots. So we have a degree of 1. You can only have, your only option is 1 root. But if I have an x squared term, right, I could have 2 complex, so I could have 2 imaginary roots, or I could have 2 real roots, okay? Just like in that last example that we did where we used the quadratic formula to solve. That was 2 imaginary roots. I had no real roots, just 2. But if I have x cubed, if my degree is in x to the 3rd power, that means that I could have 3 real roots, or I could have 2 imaginary roots, but I still need 1 real root, okay? Because I can't have 2 sets of, I can't have 4 imaginary roots in a cubic. But in a quartic, or an x to the 4th degree, I could have 4 imaginary roots, I could have 4 real roots, and I could also have 2 real and 2 imaginary, but I can't have 1 imaginary with 3 real because the imaginaries come in pairs. So given that information, we have a degree of 4, and I know the zeros are this right here. So let's think about this. I'm going to say polynomial, and you can use whatever letter you want there, is going to be x minus 4, that's this one right here. We've got x plus 7, and then we've got x minus 2i. Now remember, I said this is a degree of 4, 4th degree, x to the 4th power. So I only have 3 factors here. So that means that, remember, oh yeah, this is imaginary. This should be x plus 2i. So now I'm not going to make you put that in standard form yet, but that's how I would write my equation as a factor of linear factors. So 3 of these problems here, I promise we're almost done. And what's going to happen here is we're going to try to find a function with these degrees. So for this first one, we have a degree of 3. So we have a polynomial p of x. It's a degree of 3. I have these functions. It's going to be x minus 2. We have x minus 3. And then we have x minus 1. So this is a cubic. No problem. You should be able to multiply that out. That's fair. Now, the other thing is not only do complex fraction or complex numbers come in pairs, Okay, so imaginary numbers come in pairs, but so do roots or radicals. Okay, and so that means that if I have a -2, if I have a negative root 2, then it's also going to come in a pair with a positive root 2. Okay, so I have a degree of 4 function, and with my degree of 4 function, we know that the zeros are negative, they are negative root 2. So let's make our polynomial. We have parenthesis x plus root 2, which also means now I have x minus root 2. And then, okay, so it says the zeros are negative root 2, 1 with the multiplicity of 2. So now I've got 1, which is going to be negative x minus 1. And it has a multiplicity of 2 and root 2. So I've got negative root 2, positive root 2, and negative 1, and I've got my multiplicity of 2. That makes my quartic, my degree of 4, 2, 3, 4. We're done. For this one, find the function that has a degree of 3, and this is just the zeros, easy. P of x is just going to be x minus 1/2. It's going to be x plus 1/2, and then it'll be 3, so that'll be x minus 3. Finding the function that has a degree of 5. So we've got polynomial of x, and it says a degree of 5. So okay, -2 is a 0. So that means that you have x plus 2, and the multiplicity is 3. 1 is a 0 with multiplicity of 1. So that'll be x minus 1 to the 1 power. 0, it has the multiplicity of 1. So instead of writing x minus 0 here, I don't want to see that. Instead of doing that, I would expect that you put your 0, I would expect that you put your zeros that are 0 up in the front like that. So let's see, we have 1, 3, 4, 5, it's a 5th degree, we're done. And this would be my answer. Okay. For the next problem, it says find the polynomial that has a degree of 4. Okay, 2i, that means I have a negative 2i. And that has a multiplicity of 1. 3 is a 0 that has a multiplicity of 1. 0 is a 0 with multiplicity of 1. So we have P of x is equal to, we have x minus 2i, that's here. Then we have x plus 2i, that's this one, because it's a pair, fundamental theorem of algebra. These are multiplicities of 1, so we're good, 1. 3 is a 0 with the multiplicity of 1, so x minus 3. 0 is a 0, so I'm going to put x up front here. And we've got 1, 2, 3, 4. It's a 4th degree. All right, so like I was saying with the rational numbers before, I do want to just remind you that sometimes rational numbers come like that, a plus bc, b root c. So this, what you have to remember is that sometimes you're going to have to subtract a 0, like a quantity, all right? So just like we were doing in the other day. Suppose that a polynomial of degree 6, okay, so we have a polynomial that has a degree of 6, so it's x to the 6th power, so I'm going to go P of x equals, and I've got rational coefficients of all of this stuff, and those are zeros. As 3 of the zeros, find the other zeros right there. Okay, so this is what it's saying. I've got 3, I'm going to start with the 3i. So that means that I've got x minus 3i. Now, that is an imaginary number, so my other one is going to be x plus 3i, okay? Now I want you to look at this one that says 2 minus root 5. So the conjugate to that is going to be 2 plus root 5. But the way I write that, if you remember, all of these are the opposite. So this is going to be x minus this one, which is 2 plus root 5. And this will be x minus 2 minus root 5. Okay, and then I've got this, negative 3 plus 2i, which is the conjugate of that is negative 3 minus 2i. So I've got those two. So this would be x minus the quantity negative 3 plus 2i. And then I'd have times x minus the quantity negative 3 minus 2i. And so that would be part of your, that would be work. And then you would definitely need to fix your answer and simplify it. So you would say, I'm not asking you to multiply this out. you would then go x minus 3i times x plus 3i. But then you would have to distribute. So it'd be x minus 2 minus root 5. And then it would be x minus 2 plus root 5. It would be x minus, no, plus, right here, x plus 3 minus 2i. And then last one would be x plus 3 and then plus 2i. And then that would be the polynomial of degree 6, right? Because that's 1, 2, 3, 4, 5, 6, 6 degree. That meets the prerequisites. This is just, again, possible combinations. We talked about this right here, so that you can review that. One more of these. Is there a polynomial degree of 4 that has the zeros of these two things here? So we would say P of x is equal to, and then you would rewrite this. You would say x minus quantity 8 plus 2i and its conjugate. The conjugate is 8 minus 2i. Okay, so then you'd say x minus the quantity 8 minus 2i. And then now you've got 6 minus root 3 and its conjugate 6 plus root 3. So this would be this would be x minus the quantity 6 minus root 3. And then this would be x minus the quantity 6 plus root 3. And then that's how I would write it to start with. And then you would need to rewrite that and distribute the values P of x. So x minus 8 minus 2i, x minus 8 plus 2i, times x minus 6 plus root 3, and then x minus 6 minus root 3. And this would be a polynomial of degree 4. And even though they only gave me 2 of the zeros, this is what they did. And I'm not, like I said, I'm not asking to multiply this out, but I do expect you should know how to do that. Degree 4, we have 2 more of the same. I'm going to just rewrite this one time. So P of x, and then you would need to simplify for sure. You've got 2 minus 2i, and you've got the conjugate, which is 2 plus 2i. And then be careful with this one for the conjugate. You have negative 3 minus root 2. So this would be negative 3 plus root 2. Only the middle term changes the sign, not the negative sign. All right, so this would be x minus 2, excuse me, let me put a parenthesis there just so we can distribute later. So minus the quantity 2 minus 2i, and then you would have x minus the quantity 2 plus 2i, and then you would have x minus the quantity negative 3 plus root 2, and then you would have times the quantity x minus the quantity negative 3 minus root 2. Okay? Last problem, right? Okay, so degree 3, rational coefficients, I only have 2 zeros. So I have to know that I has a conjugate, which is negative I. So my polynomial is going to be equal to x minus I. It's going to be equal to x plus I. And it's going to be equal to x plus 4. And that's it. You would be something like this. You would absolutely be expected to multiply these out. And we've already done one like this, that where you have x plus I and x minus I, which you should know now. That is x squared plus 1. And then you would just multiply by x plus 4. And then you could get the polynomial as a cubic, like all written out. So we definitely passed all of our learning targets. Awesome job. Review this, review the fundamental theorem of algebra, your multiplicities, your end behavior, and all of that. Complete the worksheet that is posted on your slate. And thanks so much for watching, guys. I'll see you in class. Definitely come to office hours if you have any questions, right? Okay, bye.